Hello everyone, welcome to my channel. Today we are still going to look at structural analysis as we did in the previous module, the first module where we looked at a truss, how to determine the deformation of a truss using ANSYS workbench. And today we are going to look at the beam and frames, how to solve the beam and the frame in ANSYS using the workbench. So beams and frames are frequently used in construction, that is for buildings, vehicles, and many other things. The beams differ from trusses in a way that their longitudinal dimension is slightly larger than the transverse direction. And the beam can be subjected to both bending and axial loads. And for the frame, it's a combination of two or more rigidly connected beams. So today we are going to use this example of a frame structure. The material is structural steel and the I-beams. We're going to use ANSYS workbench to determine the deformation and the stresses in the frame members. So straight away we are going to begin by opening our ANSYS. Then we shall drag static structure and we shall call it our frame. So basically, if you're given a different material, you can begin by assigning a material. So today, our question is saying we are using structure steel, which is already assigned. So we can close the design engineering data and go direct to geometry. And as usual, we use the design modular. We are going to begin our sketch right away. And the most important thing is always to look at your units. We are going to be working in millimeters. You can work in meters or millimeters, it's all the same. So after analyzing that, we are going to begin by first drawing this face of our structure, the front face, which is 1.2 meters, which is 1200 millimeters. So we are going to sketch it on the XY axis. You can add a sketch there. Okay, so when our modular opens, we are going to begin sketching right away. And we've seen we're going to begin with our rectangle here, the front face, such that we get this first floor and the second floor. So we shall sketch, and I'll use a rectangle. Then I'll constrain it, make it symmetric, such that it is centered. You can see the difference. Now I can dimension it. Dimension this and dimension this. And our H1 is 1200 and our H2 is 300. So we can fit this. Okay. So after finishing this, we can still add in the vertical portions. I can put on the vertical portions, but okay, I want to teach you how to protrude it from the other side. So we can go back to our modeling, then we go to concept, then create line from sketch. So in this case, we are going to select our sketch, the one we've drawn, then we shall apply. When we apply, we shall generate. So you can see our line body has been constructed. They can make isometric. So when I make it isometric, I can still create it, I can add some frozen such that whatever I'm going to construct next is not part of this. However, since we have the same material, it can still work, but I prefer this like this, because most of the times if you're going to transform anything, it might not transform some other parts that we've just joined here. All right, so after generating this, you can see from our work we've already got this. We've got this, so we can add on this fixed points. Those are the lower section, they are the vertical section. Or I can still first construct the whole of this and I can add that there. Okay, let me first finish the upper section, then I can add the lower section. Then you learn how to protrude from this. So we are going to transform this line body. So to transform, we are going to create, then transform. So we shall translate this. So it is asking what are we going to transform or to translate. So of course I can select the whole structure and say apply. So when I apply, it is asking for direction. I can give it a direction by offsetting using the coordinates. So in this case, you can see Z. So we're going to be offsetting Z, and the distance we're going to be offsetting is 0.5 meters, which is 500 millimeters. So we're going to offset Z 500 millimeters. So you can see the body, we've transformed the body, but it's not yet created. And we are going to preserve the initial body because we are transforming this from this position to this position. So if you want to retain both the parts, you retain the first line body and the second line body. So to retain both of them, I will say yes, such that when I translate them, I have both of them. Then I can just say generate. So you can see this body is here and this body is still here. That's why when you come here, it is showing you that you have two line bodies. You can see the two line bodies. So now we need to connect the two line bodies. This is a very simpler way. When instead of creating planes, you can just transform. It's similar to mirror copying. All right, so now to connect the two, we are going to go to concept and we're going to create lines from points. So maybe let me first hide the cross-section alignments. All right, so we are going to create lines. So the line, you're going to come here, select a point, click Control, the line is formed. Then the next one, I want to connect this point to this point, the line is formed. Again, continue for the rest to get this. Yeah, so now you can see, so I can apply, and because I'm not going to transform it anymore, I can just add material. When you add material and say generate, it is going to give you, now you can see the line body, line body, line body, line body, line body, line body. We have 6 parts. Okay, so we're almost there. So we have finished with the upper section. It is full. So let us go for these lower vertical sections. So the lower vertical sections, they are 0.3 meters down. That is 300 millimeters. So we are going to put this by clicking at a point. Sometimes it is not locked in. Look at these filters. So we should select a filter for the point. Don't forget that. So when you select this point, I'm going to say, okay, let me select all the 4 points by pressing Control. Then we are going to extrude. So we are going to extrude these points to create line bodies going down. So we are going to apply, and it's going to ask the direction we are taking. So this direction we are taking, you can select, come and select from here. It's going to show you that direction. You can still reverse it if you want it in the vertical, but still you want it in the lower direction. Then we shall say apply. Then it's going to ask for the distance, and the distance is then we can generate. Yeah, so you can see what we have now. This is the section that we were given. All right, so now what is remaining is to define the section, the beams of which section, and you can see from here it is an I section. So you just come, and maybe I think we can create a boolean. When you create a boolean, it means the whole body is going to be the same, which is most of the times is good. So when you come, can create a boolean such that I have a single unit. Just control, select all the members, and that is it. Then we can apply. So when we generate, you can see now we have only one line body. When I click, it comes as a full line body. So most of the times, if it is the same material, same section, it's always better to create it as one body, line body. But if you have different materials, you don't need to create it as a boolean. Because different parts are going to be having different sections. We can have the I sections, we can have the circular section. So, but in this case, we are having one section. So we are going to go to concept, then create the section. You see there are plenty of sections here. They are rectangular, circular, there are very many I, T, L. So if you're creating different sections in one structure or frame, it's not advised to create a boolean, but if it is the same, it's always advised to create a boolean such that you have a single frame. So in this case, our question said it's an I section we are going to use. So you can zoom in and see this is an I section of our material, and you can see the width of the flange that was given. Let's see, it is 25 millimeters. It is 25, enter that, and similarly up 25 millimeters. Then we have the height of our section is 80 millimeters. 80 millimeters. Then it's 80 millimeters. Then the thickness of the flange and the web, it is 5.5. Okay, this is 5, this is 5, this is 5. Okay, so you can see our I section. Maybe, yep, it is longer, but you can fit it. That's our I section there. Then we can generate this. So now to put this I section, you can see when I click here, the I section is there in the cross sections. So when you have many cross sections, you can add another cross section. Maybe it is a rectangular section, depending on what you're drawing. So in this case, our question says everything is an I section. So we are going to attach the I section to our line body. So when I click on the line body, it is saying cross section not yet selected. Then you click on the selection, then the I section, then you can generate. So when you generate, it is not visible, right? Just come to view, then we enable, come to view, then we enable solid cross section. So now you can see our sections. You can see what we've constructed. So the next step is alignment. Alignment is very important. So look at our sections here. Look at this I section. It is flipped. It is not vertical in the right orientation. So when you're designing any construction, you have to take care of the annotation and the alignment. So we can see that this is not well aligned, this is not well aligned, this is not well aligned, this is not well aligned. However, this is well aligned and this is well aligned and the rest are well aligned. So what you do, click to this, then we select the lines because we've been using the lines for the sections. So to align, we shall click to this, then it will give you the orientation of that member and control, because we have many, control. So you see that I've selected all the members that are not properly aligned for construction purposes. So after this, you can come here, you can have alignment in X, alignment in Y, alignment in Z, rotate. Okay, so it's better to go for rotate. Then we are going to rotate this by 90 degrees. When you say enter, you can see that now we have a proper alignment. Then say generate. Okay, now you can see the right alignment of our structure. Right? Okay, so after this, can put it back in ISO. So we are done with designing our structure. So we shall go to our model and we shall edit it. It has a load along a line pressure applied of 60 kilonewtons per meter along the first level and the second level. Okay. So first we need to define our material. If it is a different material, we go to geometry and our line body. You can check it is structure steel, which is good. Then after that, we can then we shall go for mesh, and we shall use element size of 0.2. Then you can right click on mesh, or you can update from here the mesh. So we can generate the mesh. Yeah, so you can see the mesh we've obtained for our structure at 0.2. You can make it fine accordingly. Then we are going to define our boundary conditions now. Now boundary conditions, we are going, you can use this panel up, or you can just right click on structure, then you come and say, let us first put the fixed points. Then we shall activate our point and say, these lower points, control, select the 4 points, make them fixed points. Then you say apply. We'll select apply to show you all the fixed points. Then we shall apply a load, which is a line pressure. And when you go to our question, the line pressure is the same. So we are going to apply it along these edges. So we shall select that edge, control, select that edge, control, select that edge, control, select that edge, select that edge, control, select that edge, and that edge. Okay, so then we can apply. You can see both of them are highlighted, and that is asking the component. And we shall use the vector. Shall use the component, not the vector, sorry. And it is in our question, it is in the negative direction of y, which is 6 kilonewton per meter. So we shall input that negative 6000. Enter. So you can see it is applied. So we can go to our solution. Our solution, we are looking for the deformation, total deformation. Then we can still insert the beam tool to get the direct stress, the maximum and the average. Then you can right click to solve, or you can come up here and solve. So we can solve. So after it has solved, you can come to look at the deformation. So now you can see the deformation in the members. And when you come to the beam tool, you can see the direct stress. You can see the minimum combined stress and the maximum combined stress. Okay. So the other thing I want to show you is when you look at this, during construction, okay, during construction, you can see that our linear pressure is applied on the sections, but we can apply a slab or a surface. Let's see what happens when you apply a slab. So we can apply a slab at the two levels, the first level and the second level, to see. So we shall go back to our modular. You can change it from here, or you can what you can do, we can duplicate it. Okay, I think that's a better idea, to duplicate it. So I'm going to duplicate it. It's going to take some time. Okay, it is here within your time. So you can see the geometry is already ticked and the module, so it's only the setup. But what you're going to do, we are going to edit our geometry. Edit the geometry because we want to add something. We want to add a slab to see the effect of the slab on our deformation. So still it will come, and so we are going to add a surface. To add a surface, we are going first, let me hide the solid, so I remain with my structure there. Then we are going to go to concept. Then we are going to create a surface from our edges. So we have this surface. We are going to create along this edge for the first level. That is the first surface. And it's going to be, we can make it like about let me make it, okay, let me make it 20 millimeters, just for education purposes. Then we shall apply. So when you apply, we shall generate that. So you can see a surface is created at the first level, then from edges. So we can create a surface from the edges. So we can select the edges at the second level, like this. We apply, then we can apply 20 millimeters. 20 millimeters, okay. Then we can enter, sorry, 20, enter, then we can generate. So we've created two surfaces in our structure or our frame. Then what we are going to do, again, we want to create a boolean. So when you don't create a boolean, it means we are going to maybe not let me not create a boolean such that you know how to do it if you miss it. So this is our new structure, so you can save. So if you don't create a boolean, it means it's not going to be one body. So you can see we have this, we have the first surface, we have the second surface. So we are going to go back to our mesh, and we can minimize this. When we come to our module, we shall go for editing, and it is going to say update data needs to be reread. So it means we need to first update it. Then you say, okay, update it. So this updating helps you that whatever you've modified in your geometry comes back, because remember, we duplicated this flap from the first one, A to B. So it has to run the upstream data. Okay, so here it is. So our forces are still on, the line pressure, it is still on, the fixed points are still on. But before we run, there's one thing we need to know. Even our mesh needs to be redefined, because you can see it is asking for an update. But they're what we call connections. Now, because we didn't create a boolean, it means that when we come to our geometry, we shall have the line body, we have surface 1, we have surface 2. So because we didn't join to have a single body, it means we have to define the material for this surface and the material for this surface. So the material for surface 1, just click on surface body, then we assign. So this is supposed to be, most of the times it's concrete, but in the interest of learning purposes, let us go for structure, such that we don't waste out of time looking for material, blah 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 blah. Okay, then we shall assign another one, assign it still. Okay, so you see it is ticking. So after this, the material, now we need also still, we need to connect, because they're not connected. So connecting it, we can go for manual contact region. So what do we need to connect? We are going to first connect. Okay, we can connect all of them at the same time. The contact, maybe let me first hide. Okay, you can just click on this, let me hide it. Okay, let me hide the body. So the surface, the contacts I want, it's going to be for the surface 1. I select that edge, control that edge, control that edge, control that edge, right? Then I apply. So when I apply, it is showing you that you're going to connect to this body, you're going to connect another surface. So the surface, it's our target body. So our target body, I'll just right click, then I say show all surface bodies. Our surface body is back. Then I can come to geometries. I can still hide this body. Can hide this body. I can hide another surface. And still hide the other surface. So that means that when you come back to our connections, the contact body, our target body is not yet selected. So we're going to select the edges of this surface, this and that. Then we can apply. Then when you apply, you see it is saying bonded line body to surface body. So you can show the rest. You can say show all surface bodies, show all line bodies. So our structure is back. Then still that is not enough. We still have another surface to connect, the lower surface. So for the lower surface, we shall do the same thing. We shall insert a manual, so we can apply. All right, so there we go. So we're done with both contact bodies. So we can go for the mesh. Now I can show all the bodies, show the line bodies and the surface bodies. Okay, so we can go for the mesh. Point 2, we just update it. Point 2, of course you can see these are very big meshes, so you have to make them fine, like decreasing the element, but for study purposes, it's okay. Then static structure, then we can solve. Our line pressure is still there, fixed points are still there, so we can solve, see what we have. So after solution, we can come check on deformation. Okay, so what I want you to see is the maximum deformation in this case it is 1.05 exponent -3. Then for the first model we had the deformation. Okay, this is 1.3 exponent -3, and this is 1.05. So you can see that adding a slab is going to help reduce on the deformation, because now the load is shared with the slab and the beams. All right, that has been our tutorial. Thank you very much. Hope you've learned something. See you in the next class, and maybe to help you understand more, I have an assignment for you if you want to try it out. So you can try out this, try out by yourself, following what I've done. Try, get the answer, apply the loads, the fixed points, and see what you get. Otherwise, see you next time, and thank you for watching. Please subscribe